Hello everyone, in today's video I'm going to show you the step-by-step procedures on how to solve this interesting problem, that is 256 to the power sine squared x plus 256 to the power cos squared x is equal to 68, and we have to find the values of x. But before we begin, I really appreciate it if you would use 3 seconds of your time to subscribe to this channel, and also feel free to pause the video and try this first. Done? Cool. Now let's get started. First of all, let's reduce the bases on the left-hand side of the equation. 256 could be written as 4 to the power 4. Then we have to the power sine squared x plus, from here we also have 4 to the power 4 or to the power cos squared x, and this is equal to 68. Now from indices, a to the power m or to the power n could be written as a to the power m times n. So it means that straight away we can multiply this sine squared x by this 4. Likewise, we can also multiply this 4 by cos squared x. So we're going to have 4 to the power 4 sine squared x plus 4 to the power 4 cos squared x, and this is equal to 68. Now let's pay attention to the exponent. We have 4 sine squared x, and then this part we have 4 cos squared x. Now you realize that they are not the same, so solving for x becomes a little bit difficult. But as soon as we make them the same, if we have sine squared, solution will be pretty much simpler. So how can we make them the same? Now let's remember one nice equation from trigonometry, which is cos squared x plus sine squared x is equal to 1. Now if we make cos squared the subject from this equation, we're going to have cos squared x is equal to 1 minus sine squared x. So in place of cos squared x from this part, we're going to replace it with 1 minus sine squared x. So the equation now becomes 4 to the power 4 sine squared x plus 4 to the power 4 times 1 minus sine squared x, and this is equal to 68. And from here, let's distribute this 4. So we're going to have 4 to the power 4 sine squared x plus 4 to the power 4 minus 4 sine squared x, and this is equal to 68. Now from indices, once again, if we have a to the power m minus n, this is the same as a to the power m divided by a to the power n. So let's go ahead and apply this idea over here to this part, right? So we're going to have 4 to the power 4 sine squared x plus 4 to the power 4 divided by 4 to the power 4 sine squared x, and this is equal to 68. And now we see that this 4 to the power 4 sine squared x is the same as what is here. So from here, we're going to let y equal to 4 to the power 4 sine squared x, where y is never equal to 0 because of this part, right? So the equation now becomes y plus 4 to the power 4 is 256 divided by y is equal to 68. Now let's get rid of this fraction by multiplying through by y. So we're going to have y squared plus 256 is equal to 68y. And now you can see we have a very nice quadratic equation. And to solve any quadratic equation, you need to equate everything to 0. So we're going to have y to the second power minus 68y plus 256 is equal to 0. Now looking at this nice quadratic equation, we can use factoring method to solve. we're going to find two factors that when you multiply them, you'll be getting positive 256. But when you sum them up, you should get negative 68. And the values are negative 64 and then negative 4. So this equation now becomes y to the second power minus 4y minus 64y plus 256 is equal to 0. And now from these two terms, we can take y out. So we're going to have y times y minus 4. Then from the remaining two terms, we can take negative 64 out. Then times y minus 4, and this is equal to 0. Now you can see we have y minus 4 here, and then we have the exact same thing here. So let's take it out. We're going to have y minus 4. Then we are left with y here, so times y. Then this part we are left with negative 64, and this is equal to 0. Now at this point we can say that y minus 4 is equal to 0, or y minus 64 is equal to 0. Now from this equation solving for y, we have y is equal to 4, or from this equation we're going to have y is equal to 64. But remember, initially we let y equal to 4 to the power 4 sine squared x. So in place of y from this equation, we're going to put 4 to the power 4 sine squared x is equal to 4. And now you can see the bases are the same, so straight away we can equate their exponent. And remember, we have this power to be 1. So we're going to have 4 sine squared x is equal to 1. Now let's go ahead and then divide each side of the equation by 4, so that this and this will go. So we're going to have sine squared x is equal to 1 over 4. Now let's get rid of the squared by taking square root on the both sides of the equation. And remember, we have plus or minus here. And straight away, this square will cancel the square root. So we have sine x is equal to plus or minus 1 over 2. Then when y is equal to 64, we're going to have 4 to the power 4 sine squared x is equal to 64. And we can write this equation as 4 to the power 4 sine squared x is equal to 4 to the third power. And straight away you can see the bases are the same, so we can equate their exponents. So we have 4 sine squared x is equal to 3. Now let's divide each side of the equation by 4, so that this and this will go. So we're going to have sine squared x is equal to 3 over 4. Now let's get rid of the squared by taking square root on the both sides of the equation. But we have plus or minus here. Now we're going to have sine x is equal to plus or minus square root of 3 over 2. Now from the calculations, we have seen that sine x is equal to plus or minus root 3 over 2, or sine x is equal to plus or minus 1/2. So how do we solve for x in each case? First, let's draw the Cartesian plane. Then on this Cartesian plane, we're going to draw a unit circle. A unit circle is a circle with radius 1 unit. So this point is going to be 1, 0. Here is going to be 0, 1. This point is going to be 0, -1. Then lastly, here is going to be -1, 0. Now, since this is a unit circle, it means that the radius has a magnitude of 1. Now, from the question, the angle here is x degrees, right? Now, let's indicate the vertical component and then the horizontal component. Now, before we proceed, let's consider another Cartesian plane. And on this plane, we're going to draw a unit circle. Right. Then on this circle, we're going to draw the radius, which has a magnitude of 1. Now let's indicate the angle as theta and then the vertical component to be y, whilst the horizontal component is x. Now if we resolve this along the vertical component, we're going to have sine theta is equal to sine is opposite over hypotenuse. The opposite is y, so we're going to have y over the hypotenuse is 1. Therefore, it means that y is equal to sine of the angle here, which is theta. Likewise, if we resolve along the horizontal component, we're going to get cos of the angle, which is theta, is equal to x over 1. So it means that x is equal to cos theta. Now, if we bring this idea to this part, it means that this vertical component is going to be sine x, which is equal to root 3 over 2. So it means that this part is going to be root 3 over 2. Now let me get rid of this whole thing so that we will get much space to work. Nice. Now how do we find this angle in terms of degrees? Since we know opposite and then we know the hypotenuse, we can find this angle. So it means that x is equal to the sine inverse of root 3 over 2, which is equal to 60 degrees. So it means that the angle here is 60 degrees. Now let's go ahead and then change the angle here, which is 60 degrees, to radian. Now to do that, we know that 180 degrees is equal to pi radian. Therefore, 60 degrees will be equal to 60 times pi over 180 degrees. And straight away, this and this will go. 6 goes into itself 1 and then goes into 18 3 times. So we're going to have pi over 3. So it means that 60 degrees in radian is going to be pi over 3. In other words, 1 over 3 times pi. Right. Now from this equation, we know that pi is equal to 180 degrees. So from this point to this point is 180 degrees. So it means that the whole of this angle is 180 degrees. Now what does this pi over 3 here means? It means that we have to divide this whole semicircle into 3 equal parts. Now let's draw another radius here to divide the semicircle into 3 equal parts. Since we know that this angle is 60 degrees, it means that here is also 60. So from this point to this point, the total angle is going to be 60 plus 60, which is 120 degrees. So we're going to have 120 degrees here. Now how do we change this one to radian? We know that from here 180 is equal to pi, therefore 120 degrees will be equal to 120 times pi divided by 180 degrees. So straight away this will cancel this, and this is equal to 12 is the same as 6 times 2, then times pi divided by 18 is the same as 6 times 3. And we see that this is will cancel this, so we're going to have 2 pi over 3. So it means that 120 to radian is going to be 2 pi over 3. Now one important thing you should remember is that the semicircle on top of the x-axis is the positive part, then the semicircle below the x-axis is the negative part. So let me clean this whole thing so that we'll get space. And we know that the angle from this point to this point is 180 degrees, then plus 60, which is 240. So we're going to have 240 degrees here. So it means that from here to here is 240 degrees. Now let's change 240 degrees to radian. We know that 180 degrees is equal to pi radian. Therefore, 240 degrees is going to be 240 times pi over 180. This will cancel this, and we have 6 goes into 24 4 times, and then goes into 18 3 times. So we're going to have 4 pi over 3. So it means that 240 in radian is going to be 4 pi over 3. And lastly, let's divide this one into 3 parts. And this time we want the distance from this point to this point. Since the total angle of a circle is 360, let's take this angle which is 60 from 360 so that we get 300. So it means that from here to this point, the angle is 300 degrees. 300 degrees in radian is going to be 300 times pi over 180 degrees. This and this will go, 6 goes into 30 5 times and then goes into 8 3 times. So we're going to have 5 pi over 3. So it means that 300 in radian is going to be 5 pi over 3. And now we can find the values for x. Now one thing you should remember is that the semicircle on top of the x-axis is the positive part, and then the semicircle below the x-axis is the negative part. Therefore, to find x when sine x is equal to positive root 3 over 2, x is going to be from here, we're going to have pi over 3 plus 2 pi n, where n is an integer. Then another value for x, from this part we're going to have x is equal to 2 pi over 3 plus 2 pi n, where n is also an integer. Now let's go ahead and then find the values of x when sine x is equal to negative root 3 over 2. That is the semicircle below the x-axis, right? So we're going to have x is equal to 4 pi over 3 plus 2 pi n, or x is equal to this part, which is 5 pi over 3 plus 2 pi n, where n is an integer. So these are the solutions for x when sine x is equal to plus or minus square root of 3 over 2. Now let's pay attention to this one. When sine x is equal to plus or minus 1/2. So from here, let's draw another Cartesian plane. Then on this Cartesian plane, we're going to draw a unit circle, right? Then the radius of the circle has a magnitude of 1. Then on the vertical component, we're going to have 1/2 because we have sine x is equal to plus or minus 1/2. Now to find angle x along the vertical component, we're going to have x is equal to the sine inverse of 1/2, which is equal to 30 degrees. So it means that the angle here is 30 degrees. Now let's convert this 30 degrees to radian. So now we know that 180 degrees is equal to pi, therefore 30 degrees is equal to 30 times pi over 180 degrees. This and this will go, 3 goes into itself 1 and then goes into 18 6 times. So 30 degrees to radian, we're going to have pi over 6. So it means that here we have pi over 6. So this means that we have to divide the semicircle on top of the x-axis into 6 parts, right? And the shortcut to do that is draw the last part. The last part, the angle here is 30 degrees. Now let's take 30 from 180 so that the distance from here to here will be 150 degrees, right? Now if you change 150 degrees to radian, we're going to have 5 pi over 6. If we draw the radius here where this angle is 30, now we know that the distance from this point to this point is 180 plus 30, which is equal to 210 degrees. Now let's change 210 degrees to radian, and this is going to be 210 times pi over 180. This and this will go. 3 goes into 21 7 times and then goes into 18 6 times. So we're going to have 7 pi over 6. So here is going to be 7 pi over. And lastly, we're going to draw the radius here where this angle is 30 degrees. So it means that to get the whole of this angle from here to here is going to be 360 minus 30, which is equal to 330. So it means that the angle from this point to this point is 330 degrees. And if you convert 330 degrees to radian, we're going to have 11 pi over 6 if you use this procedure that I've shown you from the beginning, right? So now that we know everything, we can find x when sine x is equal to positive 1/2. And like we did before, the positive part is the part of the circle on top of the x-axis. So it means that x is equal to pi over 6 plus 2 pi n, where n is an integer. Then we also have x is equal to this one, which is 5 pi over 6 plus 2 pi n, where n is an integer. Then the value of x when sine x is equal to negative 1/2. From here, from this part, no, this is supposed to be 6 actually. Just forgive me, here is supposed to be 6. Let me get rid of this, it's a mistake. It's supposed to be 7 pi over 6, right? So the value of x is going to be 7 pi over 6 plus 2 pi n, where n belongs to integer. Then the last one, we're going to have x is equal to 11 pi over 6 plus 2 pi n, where n belongs to an integer. These are also the values of x when sine x is equal to plus or minus 1/2. So guys, if you found this video useful, please smash the like button and also subscribe if you are new. Thanks a lot for watching. Have a nice day and see you again on the next video.